All right, so we're going to be talking about unit rates. So you're just going to take your paper. I'm going to start on this side first. So a rate is starting here. A rate is is a comparison of two quantities that have different units. So for example, if I'm buying cheeseburgers, right, and it's $3 per cheeseburger, $3 for one cheeseburger, I'm comparing dollars to cheeseburgers, right? Or let's say I'm driving a car and I want to know how fast I'm going. I will compare miles to hours, right? I'll compare miles to hours. And so a rate is just a comparison between two quantities with different units, miles, hours, dollars per gallon, you know, how many uh, dollars per square foot or whatever the case is, two quantities that have different units. So a unit rate is a rate. So a unit rate is just a rate that has a denominator of one, right? So you could say, let's say gas, we're comparing dollars per gallon of gas, right? Let's say gas was $3 for 1 gallon of gas. So the unit rate for that would be 3/1, or it's $3 for 1 gallon, right? Another unit rate, I could say I'm driving 80 miles per 1 hour, right? 80 miles an hour. So those are unit rates. If it has a denominator of one, that's your unit rate. All right, and then another definition we have is complex fraction. So, um, what is a complex fraction? It means that you have a fraction in the numerator, the denominator of both. So, for instance, if I had 2/3 divided by 4/5, so that's a complex fraction because we have a fraction. The whole thing's a fraction, but the numerator and the denominator are both fractions as well. So you could keep those as fractions, or you can make them decimals and divide like that. Either way. So a complex fraction is when either the numerator or denominator or both are fractions. And I'm sorry, I should have moved the paper over. Again, complex fraction is if the numerator, denominator of both are fractions. So we have a fraction here. On top, we have 2/3 divided by 4/5. So that would be a complex fraction. So let's look at the first example. We're going to find the unit rate. They're going to give us a rate, and they're going to ask us to find the unit rate, right? So Jennifer lives 348 miles from her aunt's. If it took 6 hours to get to her aunt's house, what was her average speed? So, what was her average speed in miles per hour? So those are the quantities. Those are the units they want us to use. They want us to use miles per hour. Okay. So we start there. We always start with the label. This is a label. We always start with the label. Okay. And then once you have your label, you want to go to the rate. What was the rate they gave us? So they gave us 348 miles, right? And then they gave us 6 hours. So miles, that's my numerator. Hours is my denominator. Got 348 miles over 6. Okay, so when I'm finding unit rate, again, we discussed this in class. I want to make a proportion, and I want my unit rate. I want my unit rate to have a denominator of 1 because I want to know how many miles in 1 hour. So I want to put a denominator of 1. Up here, I don't know how many miles per hour it is, so I'm going to put an X. And then from here, I just cross multiply 6 times X, which is 6X. And then I do 348 times 1. I do 348 times 1, which is 348. I then divide by 6, x equals 58. So what does that mean? Well, this means that we have 58 miles per hour. 58 miles per 1 hour. So we can write 58 miles per hour. Example number 2 says a value pack of granola bars is $5.04. If there are 24 bars in the package, what is the cost per bar? So we start with our label. The cost per bar. So on top, I'm going to put the cost, it's 504, and per the bar is 24. Okay, I want to make my unit rate here with a denominator of 1, always for unit rate. And I put the x here. So now we have 24 times x, just 24x. Then I have 5.04, $5.04 times 1, which is just $5.04. So now I divide, because 24 times x is multiplication. That's 24. 24x means 24 times x, which is multiplication. So we do the inverse and we divide by 24. And we do the same thing on the other side. We divide by 24. So now we know that x is equal to 21 cents per bar. Okay, I'm doing the math because I've already done it, but you guys are going to have to actually divide 5.04 by 24 and get that answer. Okay, example number 3. Here we have a complex fraction. Like I told you guys, that means that the numerator and the denominator are both fractions. So what we're going to do is, again, well, I read it. Julia started her pool. Julia noticed her pool was filling at a rate of 3/4 gallon per 10 seconds. And then it tells us that 10 seconds is 1/6 of a minute. What is the unit rate in gallons per minute? So this is important because you would think you would do gallons per 10 seconds, but no, they want it in gallons per minute. So we're going to write our initial label as gallons per minute. And so I know it's filling at a rate of 3/4 of a gallon. So 3/4 per, and then it says 10 seconds. But our time period is not in seconds. Our time period is in minutes. That's why it says 1/6 of a minute. And the reason why is because if you're going by 10 seconds, there's 60 seconds in a minute, right? And so you take 60 divided by 10, you would, if you make a fraction, it would be 1/6. There's 6 10-second segments in a minute, so that's why we use 1/6. I know that's confusing, but the most important thing is for you to know that we got 1/6 of a minute because 10 seconds is 1/6 of a minute. That's why we put that there. So now we have 3/4 divided by 1/6. And so even though it's a complex fraction, we're going to do the same thing. We want to make it equal to a denominator of 1 with x on top, because again, I want that unit rate. I want to know not how much for 1/6 of a minute. I want to know how much for a minute. Okay, that's my goal. How much for 1 minute? It says gallons per 1 minute. How much for a minute? So I'll put a 1 there, and then I put the x here because I don't know that answer yet. So same deal. Excuse me, Bill. Same deal. 1/6 times x is 1/6 x. And we make it equal to 3/4 times 1, which is 3/4. And so now we have an equation that has a fraction in it. So what do, what do we do here? We multiply the fraction by the reciprocal because we have 1/6 times x. Whenever you have this fraction in front of your variable like this, we multiply by the reciprocal, multiply by 6 over 1, and that crosses out there. That leaves x by itself. We do the same thing on the side. We multiply over here by 6 over 1 because whatever to the one side, I must do to the other. So now we multiply straight across. 3 times 6 is 18. 4 times 1 is 4. So x is equal to 18 over 4. But can I simplify that? I can't. That's an improper fraction. We're going to make it a mixed number. So we do 18 divided by 4. 4 goes into 18 4 times. 4 times 4 is 16. That leaves 2. We put the 2 over the 4. So 4 and 2/4. I can simplify this 2/4 to 1/2. So x is going to equal 4 and 1/2 gallons per minute. Okay, so what you guys are going to do, you guys are going to do example 4, 5, and 6 on your own, and then bring that with you to school tomorrow.